Very good afternoon, ladies and gentlemen. I'm Vadim Ermolov, and I will be chairing this session. I'm very glad to introduce our first talk, which is entitled Information System for Calculating the Shortest Route for a Mobile Robot in a Multi-Level Environment Based on Unity. Our presenter will be Andrei Topolov. Please take your floor.
Thank you. Okay, good day. Today I would like to talk with you about information system for calculating the shortest route for mobile robot in a multi-level environment based on Unity. So my aim for today's presentation is to give you information about introduction, the problem statement, algorithm for finding the shortest path in a multi-level environment, information system for calculating the shortest path in a multi-level space based on Unity, conclusions and future work. So application of robots are used for activities that the time consuming, difficult, monotonous, humorly to health and life for humans. The practical purpose of creating the robots is to transport to them those types of activities and the robots are able to replace people during emergency rescue operation after man-made disasters in the nuclear power industry, in the chemical, oil and gas, and mining industries, and in operation to combat terrorism. Before moving to the next point, I need to see the next scheme. This scheme consists of main blocks. It's transport subsystems. It's means of locomotion, locomotion control subsystems, control subsystems. It's movement control subsystems, operation coordinating subsystem, and specialized equipment control subsystems. And thirdly, specialized subsystems. It's specialized technological equipment, specialized equipment control subsystem. Before moving before moving to the next slide, it's general movement planning. And this scheme consists of path navigation, decision making, and trajectory planning. Environments for the mobile robot operation. It's one thing to solve the problem of finding a short path on a plane, another thing in a multi-level environment. Uh, Single level, like floor surfaces, on the one floor, agriculture fields, roads, and etc. And multi-level environment, like multi-storage building, multi-tiered fields, terrax, ranges, terrains. And next slides, it's a mm, problem of phase planning in multi-level environments. This is a problem. It consists of path planning should be considered levels and transitions. Transitions. Okay. So states to validate highlighting levels and transitions. The robot's trajectory may depend on the varying degrees of destruction of the building. Actually, so Algorithm considers pace peculiarities on the levels and once the transitions touches if the movement is wrong, starting level and target level, entry and finish points, obstacles, resistance, shortest path target functions. This algorithm consists of main blocks. Is the robot able to reach and robot installation one level up and robot installation one level down. Another formulas, it's trajectorious formulas function. In order to create a character that can move along the created navigation mesh, you need to add the nav mesh again component to its object. Uh, this is radius, again sized radius, height, base offset, and steering it's a speed, angular speed, it's a maximum rotation speed of mobile robot, acceleration, stopping distance, and auto braking. To use it is enough to create two objects within the agent's reach and bind its position to the goal field of our script. Then when the application starts, our agent will already be able to reach the designed goal. When we run this thing after first creating the navigation mesh, we will find our again moving towards the target object until it's reaches it. So it's a monitor unity now mesh. Okay, a very important table. It's obstacle avoidance and finding the way. Obstacle avoidance is quality, the quality of obstacle avoidance. If you have a large number of agents, you can save CPU time by reducing the quality of obstacle avoidance. Priority, it's a lower priority. Agents will be ignored by the agents when doing a vision. The value must be between 0 and 99, where lower numbers indicate high priority. Finding the road, it's the next part of table. It's after traverse of mesh link is set to automatical follow links outside the grid. After replace, if enables the agents will to find the path against when it reaches the end of the party phase. Area mask. The area mask describes what type of areas the agent will consider when searching for a path. Okay, let's go to the next slide. So, information system for calculating the shortest path in a multi-level space based on Unity. It's a component of the system structure built on Unity, and this is a null mesh. Uh, the main component, which is a date structure that describes all the surface of the game level for which it was created by turning to it characters and null mesh agents. This is null mesh agents cylindric element. Yes, this is component that is assigned to game objects that must sequentially move around the level of mesh link. this is off mesh link. This component is necessary to create special pace at the level. Climbing, staying, enduring a portal, jumping from a platform are example where it can be done with it. Now mesh obstacle. This is obstacle cube figure. It's a now mesh obstacle, moving obstacles that are subject to physics or can change their position in some other way must have this component so that agent know about their existence and can't bypass them. So this slide shows modeling in the Unity environment from a project to a 3D model. This is a 3D map visualization of a multi-level space. Okay, experimental and validation algorithm and systems now mesh Unity. It's computer simulations results for shortest route. Three cases we considered in the modeling processes. Firstly, case it's routing without obstacles. It's zero obstacles and turns 5 and strange areas 5 moreover range of turning angles 16 and 118 degrees and started areas of the end space 47%. Secondly, it's one obstacle. This is one obstacle. This is element and time. It's 26 second routing with one obstacle, and thirdly, it's routing with two obstacles. This is obstacle and this obstacle. It's two obstacles and type modeling 31 second. Okay, and this is 3D modeling visualization for 8 for 9 staging areas and turns. Okay. So conclusions and future work. The problem of accounting for transition between environment levels is outlined. The proposed shortest path algorithm entirely calculated the optimal large of pace both within individual levels and within transaction between levels. And the proposed information system based on the algorithm and now mesh navigation system in the Unity virtual environment successful finds the shortest route for various secondary taken into account present or absence of obstacles, resistance of movement, and the robot future. And the system makes it possible to visualize a computer complicate multi-level environment and correctly determine the shortest route, which can then be overcome by an experimentally real robot. And future research should be directed towards combinate the proposed system with agent-related tools, for example, from RC Core, and order to expand the possibilities for orienting the real robots in unfamiliar areas with the estimation of energy costs for moving. So, okay, thank you for your attention. Ask questions, please.
Thank you very much. Are there any questions in the audience? If yes, please raise your hands. Before we're waiting for hands, I would like to ask you some questions. First off, I'm interested, what does a term agent mean in the setting of your work, please? What is an agent?
What's amazing? It's in most pathfinding problems a good understatement in the geometric straight line distance from the partial phase to the end point. This is algorithm that to best pace to the goal from the end of the partial phase can be longer than this stage line distance.
Do you think that
This is abstract robots. It's a visualization mobile robot.
is it a software agent in a common sense?
It's a program agent. Yes.
Okay. My second question about your simulation experiment settings. Could you please return back to your experimental slide? It's number 14 or 13, I don't remember. Please go back to your experimental representation. Yeah, this one.
These slides.
This 14 is okay. So the question is about the knowledge of your agent about the terrain. Does he know everything about the terrain, about this 3D map, or it just sees a small fragment of it before starting planning the route?
Could you clarify your questions for me?
Imagine you are an agent and you stand at the starting point. Do you see the whole terrain till the target point, or you just see a fragment of it?
Okay. This is all trajectories to use or now mesh, and robot to use trajectory function all on each level. On each level, this map.
Does he know about all the map?
All possible trajectory.
Okay,
unknown.
Okay, thank you. And what was the rationale behind choosing these 3 cases for your simulation experiments? Why just 2 obstacles? Why not choosing 3, 5, 6 dozen of obstacles?
3 cases because this is technical task modeling this mobile robot moving, and firstly it's 0 obstacle, 1 and 2 obstacles, and this map you can use 3 trajectory for moving these obstacles.
Okay, I'll try to rephrase the question. If you imagine that you have added 1 more obstacle, would your algorithm be able to compute the shortest path?
Yes, this is concepts. Yes, work for many obstacles, for many obstacles.
So why didn't you check it in your experiment?
This ex- because we considered only these cases.
Okay, thank you very much. And we have a question from Maria Kolisnik, please. Maria?
Yes, good afternoon. I have the question about did you asked or did you research different algorithms of finding the shortest route, such as Dijkstra algorithm and others, Bellman-Ford, and which is more preferable, your method, in comparison with famous methods?
Thank you. This approach allows you to evaluate the best based on the each floor of the room and based on trajectory functions in the function maximum function trajectory, and it's it's a minimum function trajectory, and it's 2D modulation coordinate x and y.
But did you compare it another methods or no? Maybe algorithm Dijkstra
We did
will
not
be.
compare it.
Okay, thank you.
Thank you.
Do we have more questions, please? Thank you very much. And it is my pleasure to present the second talk in our session. It is entitled as Analysis and Systematization of Vulnerabilities of Tron Subsystems. This talk will be given by Maria Kolisnik. Please take the floor. And,
Can I share my screen?
Please unshare your screen. Yeah, I'm asking the previous speaker to
Yes.
to remove his presentation from the screen.
Okay. One moment, please.
Maria, could you please share your presentation?
Yes, of course.
Thank you.
Do you see my screen?
Yeah, but it would be better if you switch it to the presentation mode, please.
How I can do it?
It's your presentation and your interface.
No, I can make it more large. Maybe this.
Okay, up to you.
Our topic of the research is analysis and systematization of vulnerabilities of drone subsystems. Two researchers were in this work, me, Kolisnik Marina, and Piskachev Alexander. We are present National Aerospace University, Kharkiv Aviation Institute, and Technical University of Vienna. Why our which structure of our research we can find here? Basics of the research questions such as drones and their vulnerabilities analysis, system analysis of drone, structure of the drone, goal and novelty of the research, vulnerabilities of drone analysis, severities of vulnerabilities analysis, and conclusions. Why this topic is very actual now? In our situation, in the case of the war in Ukraine, very important value have drones. And we tried to understand which vulnerabilities and how can do impossible of functioning of drones. Why this research was directed to dependability and to vulnerability analysis. There are famous literature sources like studies and research of Professor Avigenis for NASA. He provided the new approach in 1990 that cyber attacks can do unfunctioning and to make undependability of different systems which use software. In his research and in research of other researchers, we found information about software and hardware can be under cyber attacks, and it provide undependability and unfunctioning, impossible of functioning of different digital devices. And our object in this research and our subject processes and processes of functioning of drone and drone as subject of the research. We tried to understand what is inside of drone to make system analysis of this device and to try describe information about which vulnerabilities can be inside software, hardware, communication protocols of drones, and which cyber attacks can be affected, can affect these devices. And we can see here only the one example of a structure scheme of drones. We analyzed different structure schemes and we tried to find similar components to understand what is inside and what can be vulnerable to different cyber attacks inside this system, inside this device. And we can see here that drones use communication protocols. Communication protocols can be used here, very famous, which we use for data transmission in all famous devices, digital devices. And also for this system, there are some specific communication protocols. And for these specific protocols, we also analyzed in databases of vulnerabilities which types of vulnerabilities and which types of cyber attacks in these vulnerabilities can be used on drones. Also, it uses operating systems. It can be Linux, for example. Hardware in the control device of drone is similar to other digital systems, and we can find here different types of memories, random access memory, read-only memory, also specific components like microscopic devices, like specific devices to analyze, analyze data from cameras, for example, and GPS, compass. We can see here specific ports with protocols I2C, SPI, and others. Also, telemetry and actuators devices are present in this system. Also, to understand which vulnerabilities and how they can provide undependability of systems, we used standards, famous standards ISO 15408 about cybersecurity aspects of information systems. And we found information that vulnerabilities can be used for successful cyber attacks on hardware and on software of these drones. We can see here in the slide drones communication protocols. These protocols are famous and can be used here. This is only abbreviation of them. And also we can find in the paper information about other protocols and their vulnerabilities. So, the goal and novelty of the research. The goal is analysis and systematization of the most serious vulnerabilities of drone subsystems and cyber attacks that can affect them, and recommendation for their prevention, detection, and mitigation. The scientific novelty. We used system analysis of the architecture of drones. We analyzed hardware components and software components, and also we used analysis of vulnerabilities of the subsystems of drones. Also, we did systematization of vulnerabilities according to types of cyber attacks. And if we are talking about novelty, there are many papers about vulnerabilities, but they propose not the same approach. We use system analysis, so we understand what is inside the system, and after this, we try to find all vulnerabilities for different components, for different subsystems of this system. And after this, we systemized them. In papers which you can find in like different literature sources, you can find information about, for example, only communication protocols, or only for processors, or only for memory. So this systematization is more large and more complex. The practical significance of this systematization of drone vulnerabilities according to the types of cyber attacks will allow us to propose a method of prioritizing drones vulnerabilities, a method of accessing and ensuring their dependability, which will increase reliability, dependability, cybersecurity of drones. If we know the goal of the research, we will try to understand which vulnerabilities are in different components of our subsystem. So it can be vulnerability of operation system. We analyzed for last 3 years which main vulnerabilities were presented in operation system. If you can open the databases of vulnerabilities, you can find more than 51 vulnerabilities for the 1 year. So we tried to find more large influence of vulnerabilities and cyber attacks, which can provide DDoS and deny of services, so unfunctioning of this system. We find this information, and after this we proposed a classification for this protocol, which type of cyber attacks and which numbers of vulnerabilities can provide this cyber attack, and you can see this information for 2-3 years. Also, in NTP protocol, we found that it can be DOS, brute force, remote command execution, script attacks, command injections. Also about VPN. Yes, in drones can be used with VPN. You can find that there are some VPN cybersecurity risks, and in vulnerabilities databases, we use different of them. We use databases from, for example, NIST, from NISA, from Greenbone, and others. And we can find that really for VPN there are vulnerabilities, and we need to understand that these vulnerabilities can be used for successful cyber attacks. Also, protocol SNMP can be used here, and also we can find information about types of cyber attacks on these vulnerabilities and numbers of vulnerabilities. Also, MQTT protocol can be used, XMPP. Also, there are some vulnerabilities in processors. In drones, you can find that microcontrollers can be used and some types of processors. And we can find that Meltdown and Spectre, two types of vulnerabilities, can be inside these devices. Specific protocols. Secure file transfer protocol has vulnerability. Universal asynchronous transmitter. Also, constrained application protocol, also they have vulnerabilities, and we need to understand that they can provide unfunctioning of drones and successful cyber attacks. Also, SPI protocol, serial peripheral interface controller area network protocol, real-time protocol, and RTCP protocol has vulnerabilities. And after this, we proposed classification, systematization of vulnerabilities and their severity for different types of cyber attacks. And you can see here, for example, for DOS attacks, because in our paper you can find for all types of very often cyber attacks on drones, and the most important and the most this type of cyber attack provide unfunctioning of the system. And you can see that almost all protocols which can be used in drones are vulnerable, and they have vulnerabilities. We can find severities in different databases. In NVD, this is from NIST vulnerability database, and severities of them are not low, they are high, so it can be used for successful cyber attacks. CVE details and other databases, because now we have different databases, for example, Red Hat, Tails, open source vulnerability database, ENISA, common vulnerability enumeration, the Open Web Application Security Project, and others. And we can find that in NVD, most whole information about different types of vulnerabilities and cyber attacks with severities. You can find here example of graphical dependencies, and you can see protocols for DOS attacks in abscess, axis, and severity of cyber attacks. Why we have so large and so complex graphics here? Because you can find in three types of databases, you can find information which severity for this vulnerability they have. And if we will use delta here, we can't propose for three databases this information. But now you can see how they are different in different databases. And also we did the conclusion here that database of NVD is more complex and more whole. Also information about different types of cyber attacks. This is only examples because we have for all types of cyber attacks and vulnerabilities.
Maria, we can't hear you.
But number of VPN vulnerabilities has increased recently. And we need to do something for their protection. Analysis showed that vulnerabilities of drones are in the used general information transfer protocols in hardware. It can be used for DOS attacks, man-in-the-middle attacks, and remote code execution attacks very intensively. The analysis and systematization of vulnerabilities and cyber attacks on drones will allow drone manufacturers and users to propose new measures and update recommendations for ensuring cybersecurity for all drones components. So, in future research, we will propose some methods for prioritization of drone vulnerabilities, method of evaluation and ensuring their dependability, which will increase dependability and cybersecurity of drones. Thank you for your attention. You can find here information about our group, our team of researchers, and please ask your questions.
Thank you very much, Maria. Yeah, please submit your intention to ask a question by raising a hand. And
Sorry, I don't hear you.
still can't hear me?
May I ask you now? I think
Yes, please.
Yeah.
can you give some examples of processor vulnerabilities? Talked about in your report, but what kind of examples maybe? What do you mean about in processor vulnerabilities?
It is famous information from databases of vulnerabilities that hardware and software have vulnerabilities inside of this. Vulnerabilities, this is a hole which can uses attacker to make a successful cyber attack. And we need patch on this to protect our hardware or software. About processors to these vulnerabilities, found different producers of processors, and also they found these vulnerabilities inside, for example, PLCs, programmable logical controllers, and other systems. So inside of them, it was proved that there are vulnerabilities of software and vulnerabilities of hardware. And this is open information, so you can find all of these vulnerabilities in databases, in open databases, from NIST, for example, from CVE, from MITRE database and others.
Okay, thank you very much.
Thank you. More questions, please? Okay, I have my own question. Could you please clarify to the audience if you have validated your findings somehow? Did you really check and validate that the vulnerabilities and the severity levels that you identified are correct?
But severity are also you can find inside the database, and this severity you can in different databases are different. How they understand which severity is for this vulnerability? They ask different companies. For example, Red Hat did this research, or SUSE and others. They use methods of measurement of severity and to propose their result inside. They propose in form to NIST, for example, and NIST and CERT, they ask producers of different equipment, they ask different companies who are involved in cybersecurity protection, and after this they propose to send to them information about severities, information about vulnerabilities of different components. So this information not from me, I only systemized, analyzed this, and did research how it can be in different databases and which vulnerabilities can be used for drone subsystems. Because if you open the database, you can also try to find this database. It is open source. And you can see that it is table with many different vulnerabilities. But you have to understand which vulnerabilities can provide unfunctioning of the system. So it was our work. We found this and we proposed.
Thank you very much. And could you
systematization.
please summarize in a sentence what is the contribution of this research you present today?
Our contribution was systematization and analysis of different types of vulnerabilities and cyber attacks on drones.
So you just extracted
Drone.
this information from the publicly available databases, filtering
Yes, and
in the drone information, right?
Yes, we did
Okay.
system analysis of drone. So what is inside of this,
Okay.
and which vulnerabilities can be inside of drone. So we have to understand what is inside, and according to standard IEC 62443 and ISO 15408, we need the first to make analysis of vulnerabilities, and after this we can evaluate the risks of cyber attacks on different objects, on different subjects.
Okay.
Our subject of the research was drone.
Thank you very much. More questions, please? No more questions. Thank you. And
Thank you.
I'm glad to introduce our next talk. The title is Helicopters, Turboshaft Engines, Parameters Identification using Neural Network Technologies based on the Kalman filter. The presenter is Serhiy Vladov. Please take a floor.
Good day. Do you make my presentation? Do you see my slides?
Yeah, could you please switch it to the presentation mode?
My name is Serhiy Vladov. I presentation.
Could you please switch your slides to the presentation mode?
F5.
Yeah, it could be good to press F5. No, just once, not
Yeah.
several times.
Yes. Yes. With your permission, I present a work. Yes.
Натисніть F5.
Yes. Do you see my slide, my presentation?
You can use also
If you look at here, you'll see presentation tab there. If you go into the presentation tab,
Yes.
slideshow.
Slideshow. 1 second. I'm sorry.
you're welcome.
I'm sorry. Yes. Look. Yes. Yes.
Okay, go ahead.
Yes. Good afternoon. With your permission, I present a work. Helicopters, turboshaft engines, parameters, identification using neural network technologies based on the Kalman filter. Helicopters, turboshaft engine are complex nonlinear systems, the characteristics of which have a significant scatter. The quality of the built-in mathematical models of helicopters turboshaft engine that are part of the automatic control system largely determines the quality of control and the possibility of using modern mathematical apparatus for the synthesis of automatic control system, as well as operating tools, solving the task of automatic control system adaptation, as well as real-time condition monitoring and failure diagnostics, inevitably requires the use of identification methods using artificial intelligence tools. For example, neural networks. In this case, the structure and accuracy of the applied mathematical model are determined the nature in the communication channel and in the measurement channel due to sensor error and communication channel interference. That's why an ongoing task to ensure the accuracy of parameter identification taking into account calculated data obtained using the built-in model and data from current onboard measurements. In connection with the foregoing, the goal of the work is to improve the accuracy of helicopter's turboshaft engine parameters identification by using neural network technologies, namely training the multidimensional Kalman filter at the output of the built-in mathematical dynamic model of identification, developed on the basis of engine's dynamic and throttle characteristics, which make it possible to identify the parameters and simulate the operation of the engine in stationary and dynamic models. Multidimensional filtering is carried out according to three helicopters' turboshaft engine thermogas dynamic parameters, which are recorded on board the helicopters. We used and analyzed for the TV3117 turboshaft engine, which is part of the power plant of the Mi-8 MTV helicopter. To prove the ergodicity of the process, the feasibility of the Slutsky
I'm
condition.
very sorry for interrupting you, Sergey.
Yes.
We are still on the first title slide in your presentation. Is it intentional? Do you do it intentionally? We do see the first slide of your presentation. Are you going to change your slides?
You don't see my slides?
I do see the first slide. And nothing more.
I don't know because I listed in my slides.
Okay, please continue.
I'm sorry.
You're welcome.
A neural network of radial basis functions RBA with 5 inputs is taken as a neural network, 3 of which are responsible for the input parameters and 2 specify the model error of the measurement error. It is known that RBF network model an arbitrary nonlinear function using only one intermediate layer, thereby eliminating the need to decide on the number of layers. Secondly, the parameters of the linear combination in the output layer can be optimized using well-known linear optimization methods that are fast and do not suffer from local minimum that interfere with training using the backpropagation algorithm. Therefore, the RBF network train very quickly, an order of magnitude faster than using the backpropagation algorithm. The neural network training results are shown in this figure. As can be seen from left figure with 80 neurons in the hidden layer, the smallest training error of the neural network is archived. That is, the optimal structure of the neural network is 5.18.3. Diagrams of the dependence of the change in these values of the number of epoch of network training are shown in bottom figure. As can be seen from this figure, the accuracy indicator approaches 1 and loss indicator tends to 0, which indicates the high accuracy of the model and its minimal error. The task of developing an algorithm is reduced to modeling mathematical expression to calculate the specific values at each step. Calculation in the multidimensional Kalman filtering algorithm were based on the dispersion of the model and sensors along the coordinates of thermogas dynamic parameters which are recorded on board the helicopter, obtained by statistical processing and flight test data of the TV3117 turboshaft engine. The generalized block diagram of the model of the multidimensional Kalman filter, which performs real-time simulation identification by 3 coordinates of thermogas gas dynamic parameters, is shown in top figure. A detailed functional diagram of filtering along one coordinate and is shown in bottom figure. In the model experiment, the values of the coordinates of the column vector of readings of the sensors under noise conditions were modeled by superimposing several types of noise on the calculated values. Gaussian noise, real noise extracted from experimental data obtained during flight test of the TV3117 engine for the considered modes and types of input signals, several high-frequency sinusoids, and other. The results of filtering under the action of combined noise were when applying input signal that provide a change in the identified values in the engine operating range for various input signal. Along one coordinate are shown in this slide. This slide shown on the results of a comparative analysis of the identification of the parameters of TV3117 turboshaft engine, determining errors of the first and seventh kind. It follows from table that the use of the multidimensional Kalman filter neural network reduced error by an average of 20% compared to the other results. The conclusions are presented in this slide. I am sorry, but you don't see my presentation. I don't know for this. Thank you very much.
Thank you very much, Sergey, for a very informative presentation. Do you have any questions, please? Are there any questions in the audience? Alexei, please.
Yeah, my remark actually about the presentation that you need to use a bigger font because presentation is it's not the text that you speak. Presentation is for us for listeners to understand the key points, and then you add your text. So you don't need to put all your text on your presentation. Then you can afford to increase your font size. Okay. Because it's really hard to read from the screen a very small font.
Alexei, thank you very much. Do you have more questions, comments, suggestions? No? Thanks. Thank you, Sergey.
Thank you, thank you. I make a presentation in chat, but and
You mean
email.
in Chat GPT or what?
No, no, for email, for your email and chat for this conference.
Okay, thank you.
Thank you.
And it is my great pleasure to introduce the next talk in our section. It's on modification of fuzzy topses based on various proximity coefficients, metrics, and shapes of fuzzy sets. The presenter is Evgen Sidenko. Please take the
Good
floor.
afternoon. Good afternoon, dear participants. Do you see my presentation in full screen?
Yeah, it's fine, thank you.
Okay. Thank you for presenting our paper on modification of fuzzy topses based on various proximity coefficients, metrics, and shapes of fuzzy sets by Dmitro Hapishko, Evgen Sidenko, Galina Kondratenko, Yuri Zhukov, and Yuri Kondratenko from great city Mykolaiv. And choosing optimal innovative projects as one of the multi-criteria decision-making tasks has become quite popular and widespread in any field of activity. The relevance of this work lies is the need for qualitative evaluation of innovative projects, which are characterized by various technical and economic indicators, and as a rule, significant capital investments are required for their implementation. So, the goal of this work is to modify the fuzzy topses method for solving the multi-criteria decision-making problems in the fuzzy conditions and variability of the shapes of fuzzy sets, in particular when we're choosing the optimal innovative projects. To solve the set goal, it is necessary to perform the following tasks. For the first, overview the current state of this problem. The next one is analysis of recent research and publications. The next is overview of MCDM methods, then modification of the fuzzy topses method, and of course, software implementation. And to modify the fuzzy topses methods, we use Euclidean distance, Hamming distance, and Chebyshev distance. To determine the proximity coefficients. And another element of the modification of this fuzzy topses methods to calculate results using various shapes of fuzzy sets, the most popular triangular, trapezoidal, and Gaussian membership function. Innovative projects are a set of actions aimed at creating and promotion new high-tech products on the market that have limited resources. And on the slide, you can see, for example, several Ukrainian sites, our government, where we can registrate own high-tech products like as innovative products and so on. But in order for investors and participants not to lose their funds, it is necessary to evaluate the effectiveness of the innovative project when financing it. Therefore, in order to take into account all criteria for evaluating innovative projects and possible variance of quantitative and qualitative data, it will be appropriate and convenient to use such a method as fuzzy topses. On this slide, you can see some different new publications where authors using topses and fuzzy topses method for different tasks, for example, selecting best family car, cloud service provider selection, and so on. And having analyzed all the above mentioned publications, it can be seen that this fuzzy topses method is widely used in many different areas. At the same time, it should be known that in existing research and development, there is no possibility of choosing the shape of fuzzy sets when evaluating alternatives and criteria, and there is also no possibility of changing the metric for choosing the optimal solution. To demonstrate the operation of the modified fuzzy topses method for solving the task of evaluation and selection of an innovative project, the following 14 alternatives projects were determined, which were presented at the startup project competition. And also the following 10 criteria are defined for the evaluation of relevant projects. For example, potential clients, relevance and social significance, project idea, project issues, market research, and so on. For the first step, it was to define linguistic terms for criteria and alternatives, and we define 7 linguistic terms, and they are fuzzy triangular number, trapezoidal, and Gaussian numbers. On this slide, you can see that all experts assessed in linguistic form criteria and alternatives, and the experts were specialists in the field of innovative project. For example, first expert evaluate the second criteria as high linguistic term. Then the estimates were converted into fuzzy numbers. This modification of the method makes it possible to use 3 shapes of fuzzy sets: triangular, trapezoidal, and Gaussian membership functions. And some calculations of this conversion you can see on this figure 3 and figure 4. The next step is to average the evaluations of the criteria and alternatives using this simple formula. The next, averaged evaluations of the alternatives were normalized, and a weighted normalized matrix of the averaged evaluations of the alternatives were constructed. And next, fuzzy positive ideal solution and fuzzy negative ideal solution are found. After that, the distance of each alternative to this fuzzy positive ideal solution, fuzzy negative ideal solution, was calculated. On this slide, you can see the result of proximity coefficients, which was calculated. And also, after that, alternatives were ranked. And the top 3 projects using triangular fuzzy number have the following proximity coefficients indicator. Startup or innovative project CyberStick is 0.959. It was the first place. A Holomedia system is 0.52 second place, and Guppy services is 0.52 third place. And also using another different trapezoidal numbers and Gaussian numbers, we see that CyberStick is also the first place. For convenient use of the modified fuzzy Topsis method when solving various problems, not only for choosing the best innovative project, a corresponding decision support system was created. And on this slide, you can see that the client can choose a number of criteria, number of alternatives, models of triangular, trapezoidal, and Gaussian fuzzy numbers. This DSS provides an opportunity to consider existing linguistic terms with in our paper 7 linguistic terms, and also add own linguistic terms. For example, term L with fuzzy number or with Gaussian membership function. When creating linguistic terms, it is possible to consider the corresponding fuzzy numbers on the graph, and also for convenient viewing of created terms, the option to highlight, you can see this, the selected term has been added. In addition, the possibility of data correction is provided. A template was also created that reflects the correctness of data entry and into database. According to the results obtained by calculating the Euclidean distance, the resulting ranking has very close values, differing by individual alternatives. The results obtained when using the Hamming distance have the same result regardless of the type of fuzzy number. According to the results using Chebyshev distance, a result that differs from the previous results was obtained. The results are significantly worse than when using another two distance. As conclusions, I would like to say that within the framework of this work, the following tasks were successfully completed. Review current state, analyze the last research and publications, review MCDM methods, fuzzy topsis method was modified, and also software implementation has been developed. Thank you for your attention.
Thank you very much. Are there any questions from the audience, please? Okay. I have a question because I did
Yes,
not.
please.
I did not fully understand what is the application of this method that you have developed. And
What about application? Yeah.
what's your use case? Did you evaluate your work based on a use case or a case study or what?
Use case or case study?
Where did you take your data from?
Well, okay, I understand. Thank you. We take our data. We took our data from startup competitions, and in that competition were 14 innovative projects, which evaluated by 10 criteria.
Could you please provide more details about the data set you used? How many projects? How many details on every project? What is the source information about the project? Is it in a tabular form or it's just a natural language text? What
Yeah.
is
This different if you talked about take about this alternatives, it was startups. For example, MP board, it was specific board for different painting.
No, just please stop. I don't care about the startups and what they proposed. I'm asking about the nature of data you used in your work. How the proposals were presented by data.
Our data is experts evaluate each alternative according linguistic term which are previously indicated.
Okay, how many experts were there on each proposal?
Six experts.
Thank you. And
thank you.
How did you validate your result?
We validate our result according another two methods, AHP analytic hierarchy process method and also ARAS method, and they also gave us the same results, and according to startup competition, also the first place was for this CyberStick innovative project.
Okay, so you compared to the ground truth, or you didn't?
Yeah, compare with another methods, and
this is not the comparison with the ground truth. I'm sorry. Did you compare with the real outcome of the experts' evaluation, or you didn't?
Yeah, we compare with the. Yeah.
Thank you. More questions, please? Do we have more questions? Could you please open the chart? Hey guys, the chart. Could you please open it?
Chat.
Okay. Okay. So no more questions. Thank you very much.
Thank
It was
you.
a very,
for
very
your-
interesting presentation, and it closes our session. Thank you very much to all of you, and I'm looking forward to meeting you once again somewhere in the future. Goodbye.
Thank you so much. Goodbye.
Goodbye.
Thank you. Goodbye.